KEQ calculations. So how do you do KEQ calculations? Whenever you're given anything with KEQ anything, the first thing you have to do is to write the KEQ expression and to remember to include only things that are gases or are aqueous. So the subscript G or the subscript AQ. Then you plug the numbers in to solve. Remember that KEQ has no units, and remember that concentration, anything that's in brackets, has to have the units of moles per liter or molarity. So here's an example. Given the reaction below, and we always have to give you the reaction, find the KEQ if 2 moles of nitrogen gas, 6 moles of hydrogen gas, and 5 moles of ammonia exist at equilibrium in a 3-liter container. So first thing, you have to remember that the 2, 6, and 5 are moles, not moles per liter. So the first thing I have to do is to convert all of these into concentration units by dividing the moles that are given by the volume of my container. So the concentration of ammonia will be 2.5 molar, hydrogen gas will be 3 molar, and the nitrogen gas will be 1 molar. So I first start out by writing the KEQ expression. I put my products, and I put the coefficient as the power, so NH3 squared, and I put that over N2 and H2 because 3 is the coefficient to the 3rd power. So again, I take my product and I take it to the coefficient over my reactants. N2 has no coefficient, so it's to the 1st power, and then H2 to the 3rd power because its coefficient is 3. I've double-checked that all of these are gases, so I can include them all. Now I just plug in the numbers that I have. So 2.5 goes in for NH3, 1 is for N2, and 3 is for H2. And then I take them to whatever power I'm supposed to. So it's 2.5 to the 2nd power over 1 times the quantity 3 to the 3rd power, and that becomes 0.6944. So again, it's what we call a dimensionless constant. It doesn't have any units to it. Example B. So again, doing the same type of thing. Given the following reaction, hydrogen gas plus iodine gas yields hydrogen iodide gas. What is the KEQ? If I give you the KEQ is equal to 2.6, and the concentration of H2 and I2 are both the same at 1.8 molar, what is the concentration of HI gas? So again, I start out with my KEQ expression, HI squared over H2 times I2. These are both in molarity units, so I can just plug them in. KEQ is equal to 2.6, so all I'm doing is solving for HI, and my HI ends up being 2.9 molar. And the final one, if the KEQ value of H2 plus I2 yields 2HI is 4 times 10 to the negative 3, so obviously different conditions than example B, what is the KEQ value of 2HI going to H2 plus I2? In other words, the composition reaction is 4 times 10 to the negative 3rd. What's the KEQ value of the decomposition reaction? So what you should see is the relationship between these two equations is that they are opposite. One is a composition reaction, the other is the decomposition reaction. So the KEQ value, if it's the products over the reactants, then what were products here become reactants here, and what were reactants here become products. So basically I take the reciprocal. So the KEQ value of the reverse reaction is the reciprocal of the KEQ value of the forward reaction. So KEQ value of the reverse reaction would be 1 over 4 times 10 to the negative 3rd, or 250. So this is one of those questions where at first glance you're looking at it going, how am I supposed to know this? I don't know any of the concentrations of any of my gases, until you realize, oh, the relationship between these two equations is that they're opposite, so I just take the reciprocal of the KEQ value.